Hi guys, today we're going to do the final part here on calculations, is to perform calculations, use of mole concept involving volumes and concentrations of solutions. So on solutions here, there are two types of solutions, or two types of titrations on solutions. Okay, so we're going to do, first of all, is acid-base titration. All right, how many solutions we do with titrations? Right, okay, is acid-base, acid and base titrations. Remember, this titrations. Okay, you will learn this in your practicals. The second one, of course, is redox titrations. Okay, redox titrations. Now, just to go over with you, acid-base, there are three types. Okay, I'll show you here. There are three types of acid-base, like here, right? So first of all, is strong acid, strong base. Okay, strong acid, strong base. Example, HCl, NaOH, or you can use H2SO4. Okay, or nitric acid. All these are strong acids. A strong base is normally NaOH or KOH is okay. Now, these two are the common ones, but this is the most common. The weak acid and strong base, normally it's an organic acid, like this one here, ethanol acid. Now, this can come from, this is called a monocarboxylic acid. Okay? Let me just record the time first. Okay. Now you will see that I will bring you ideas to, or the question in particular, they go to dicarboxylic acid. I show it means up to, okay? That means there are two function group here. And of course, a tri, they won't go too far after that. Tricarboxylic acid, okay? You have to know, you have to get used to it, okay? So there's a weak acid here, strong base, same thing here. Now, the strong base and weak acid is very common in this thing called back titration, which we do next week. I don't have time now. Okay, the strong acid, now this is a weak base, which is ammonia. All right? So ammonia will dissolve in water and can undergo reaction with the strong acid here. Okay, let's start now. All these questions I got from the main notes, okay? So I put them out so that I can do it easily, faster, we can finish it more, and you can do more work, okay? So the first one, right? Now, of course, it's strong acid, strong base. Why strong and strong base? Because it's HCl and with NaOH, okay? Now, so it says here, 20.50 cm cube of 0.100 mole per dm cube of HCl. M means molarity, okay? This one is Form 5 work. It means moles per dm cube. You have to know that, I can't be always going back to Form 5. Neutralizes 25.0 cm cube of solution of NaOH. Okay, find number of moles of HCl used, number of moles of NaOH reacted, and concentration in moles per dm cube and grams per dm cube. Now, you must understand there are a few formulas that you need to know. All right, I'm going to go back to here. Okay, about 30 something, 34, let's go. Okay, 38. Now here is all the formulas you need to know, like here. Okay, remember we did the gas, isn't it? Now for solutions, right? The first one, of course, is very simple, right? The number of moles is what? The first is N equals to, sorry, there's a click here. N equals to M over AR, or M over MR. This is famous for mass. Okay, mass, anything you weight. Okay, concentration, very simple. Molarity, this for solutions. Molarity is normally called molarity or moles per dm cube. Okay, it's equal to number of moles over volume. Volume, of course, must be in dm cube. So normally you change it to dm cube, okay? Or this to m here. Normally we use number of moles equals to m times v, isn't it? So it must be in dm cube. Yeah. Okay, so now this is very useful. The concentration, I normally put CONC is grams per dm cube. It's equal to mass over the volume. Mass will be in grams, so this is dm cube. Okay. Of course, this is a very useful equation. Most people, they do it, I don't know, sideways, upways, I don't know. So concentration in grams per dm cube is equal to moles per dm cube times the mR. Yeah, you see this is used for very constantly now. Okay, now these are 4 equations that you need to know by heart to do the calculations here. Okay, now how I'm teaching you the skills, like how to have a bath, you know, how to cut a chicken, how skills. Okay, what do you do in such a titration? Okay, the first thing you do is, of course, in this case here, if you can draw a diagram, that'd be great. All right, which means here you can draw a solution, or between here is your burette. Later it's very good to draw. I should have put one. Here, of course, is your acid here. Okay, here is your HCl. And what's the volume here? Okay, volume here, you can put either way. Okay, actually here, sorry, here actually because it's 25, right? Fixed one here. So if it's 25, okay, 25 here. Normally 25 is you prepare, isn't it? So here put anyway, doesn't matter. Okay, either way is okay. So volume used, how much V1 is equal to how much? 25.0 cm cube. Okay, the molarity you don't know. Here is your acid. So a picture paints 1,000 words, all right? This is HCl. So the V2, how much you use here? 20.50. So you can actually see, we all learn by pictures. Like you see movies, isn't it? If people see a movie, then read a book, isn't it? Full. M2 is how much? 0.100. Okay, so write the balance equation. Is it balanced? Balance it. So arrow here. So here it's good to put down all, see, equation, the first thing. Secondly, put down all the details. What do you mean by details? Detail means the volume and the molarity, all the grams per dm cube. Here you're given V2, you put V2 here, 20.50 cm cube, okay? Here's M2, molarity equals to 0.100, okay? Here V1 equals to 25.0 cm cube. You don't know the M1, in fact, you want to find the M1, okay? So they lead you. This is the way they lead you actually in practicals, okay? One by one. But sometimes in your form 5, if you do SPM, use this formula. M1V1 over M2 V2 equals to N1 over N2. You can, but normally this one is just for quick calculation. But normally in your practical, they want step by step. Also in paper 2, okay? So we do step by step. They want to see whether you understand or not. Otherwise, you're just like a cow, you know, like some copycat. Okay, so they ask you the first of all, the number of moles of HCl, very simple, right? And so NHCl, okay? Do as I do, okay? N means more, number of moles, HCl, the subscript here. It's equal to what? MV over 1000. Okay, I do this all because I want a space here, that's all. So it's equal to 20.5 times 0.1 over 1000. Okay, here's shift 1, here's shift 1, 1, 2, 3. So it equals to 0.002. 5 moles, okay now. Yep. Yeah, I want to make sure life getting okay. Now this number of moles is used to titrate, neutralize your NaOH. Okay. So now let's say what's the relationship? Remember stoichiometry from the equation here. 1 mole reacts with 1 mole, isn't it? To give you this the ratio 1 mole and 1 mole is not. So it's 1, 1, 1. So you want to find here, see, you want to find the number of moles of HCl. Here first, sorry, this A. I put A here. A. Now B. Number of moles of NaOH. Okay, so it's good to put number of moles of NaOH subscript over number of moles of HCl. What is the ratio like from the equation? 1 mole is to 1 mole over 1 here. Yeah. So quite simple. You can do it straight away here. So number of moles of NaOH is equals to number of moles of HCl is here. So 0.0025 times 1 now. So same, isn't it? 0.0025. Most of us, we just look at the mole ratio from the equation, right? So it's same here, 1 mole is to 1 mole, so it's no problem, isn't it? Right? You can do it straight away or whatever. But here is important. It's present, dissolved in what volume? In the titrated volume, is it? Which is what volume is it? 25. See here. Here, 25. Dissolved in 25.0 cm cube. So this is inside here. That's why they ask you the next question is the concentration, right, in moles per dm cube and grams per dm cube. So let's do the first one first. Okay, now then C. So molarity is equals to what? Number of moles or volume is it in dm cube. Okay, so very simple. Number of moles is how much in this one here? 0.0025 over here is 25 or 1000. See, I'm doing step by step. So you better know how to do it. If you don't in Form 5, you better learn now. Or else drop chemistry and do something simpler. Chemistry is not easy. You want to learn, then you better buck up and learn something. Okay? And learn it not only once, perfectly, 10 times until you get into your bloody head. Okay? So it's 0.100 moles per dm cube. Okay? Now to find, this is number one, to find grams per dm cube, very simple. I told you the equations here. See? In grams per dm cube, yeah? Alright? So in grams per dm cube, very simple. You apply the formula, you can solve it straight away. Okay? Concentration in grams per dm cube is equals to molarity in moles per dm cube times what? Times your MR. Okay, right? So here they ask you, okay, moles per dm cube is equals to 0.100. Now what is the MR? MR what? MR of your acid, okay, of NaOH here. NaOH, NaOH what is NaOH? What is MR? NaOH, okay, let's put it here. NaOH is 23 plus 16 plus 1 is 40. Apa perlu? So 40. So what's the answer? 4.00 grams per dm cube. Now always follow the accuracy of 2 decimal places here. Okay? They put 3 decimal places in, so you want to put 1 more, can also. Okay? But normally if with the number here, 2 will do already. Okay? Easy, isn't it? Alright, now this is an easy one. Now let's look at this one now. Here I have a diprotic acid. It's a bit different, that's all. Okay, it's called a diprotic acid. Protic acid. I'll give all the names, or it's called a dibasic acid. Why call it dibasic acid? This is acid. Because the first one, HCl, is called monobasic acid. HCl is called a monobasic acid. Okay, monobasic acid. Why? 1 mole react with 1 mole of NaOH. Okay, for complete what? Titration. So 1 mole, 1 mole. So it's a monobasic, right? H2SO4, like here, right? 1 mole, right? How many moles? 2 moles. Why? Because this SO4 is 2 minus N. So it's here is it. So that's why it's called a dibasic acid. You can also have a tribasic acid, for example, a phosphorus acid, H3. Phosphorus acid is found in your Coca-Cola and Pepsi Cola. They dissolve it inside here. They say it's good for you, blah blah blah. But it's good for boys, but actually it will cause the half-life of carbon to remain there longer, so the bubbles won't come out so fast. So that 1 mole give you 3 moles of H+. This is called triprotic acid. Triprotic acid or a tribasic acid. Simple as that, right? Why? Because 1 mole has 3 moles of NaOH for complete neutralization. You can do it yourself, okay? I don't have time to go through all this video. Now this is very simple, same thing here, right? 18.50 cm cube of 2 molar H2SO4 neutralizes 25 cm cube of NaOH. Find the moles of H2SO4, titration, number of moles of NaOH, and so forth. So what to do first? You can draw the diagram first, but let's say I skip the diagram, okay? Write the balance equation, now this one here, okay? After the equation, what I do? Details, all right? Details. Details means what? Well, how many, what volume, and blah, blah, blah. Here, V1 is equal to how much? 18.50 cm cube. And molarity is how much? 0.200. Okay, here V2 given what? Yeah, 25.0 cm cube. Anything given here? Molarity don't have, we put a question mark here. Okay, which means we find these are normal because for solutions. Okay, number of moles of H2SO4, very simple because why? You start with a known, is it? From a known to the unknown. So what is known here is, of course, your number of moles of H2SO4. So number 1, A, number of moles of H2SO4. So put a bottom here, subscript here. This goes to what? MV, or 1000. Yeah? So what is M? 0.2 times what is V? 18.5 over what? 0.58, 1000. Okay, which is equals to, I got it here. Okay, 3.7. See, I did on my homework, so it's faster, no? Moles. Okay, so to find the number of moles here, I got here, I first one here, and number of moles of NaOH, very simple. So always use the ratio if you have a problem. Of course, here you can see, here's 1 is to 2, you know? So obviously, if it's 3.7, then 3 here be what? This times 2, isn't it? Or you can, for full proof, number of moles beer, number of moles of NaOH over number of moles of H2SO4. For its full proof equals to what's the ratio? 2 over 1. So this one is from here. So you can put straight away inside there. Alright? So number of moles of NaOH equals to 2 times 3.7 10 to the power of minus 3 equals to, the value is 7.4 times 10 to the power of minus 3. Now, dissolve in what volume? Very important. What's volume you use here for your NaOH? 25 now. See here? Right? So it's 25.0 cm cube. So therefore, can you find the molarity of NaOH? Obviously. Right. There's no more juice. Okay, OH. Why? What's wrong, baby? Okay, NaOH. Sometimes, technology is not that great, but it's good, help me a lot. Okay, number of moles over volume. Okay, number of moles is 7.4, the power of minus 3. What's the volume? 25 over 1000. Why? Because this volume must be in Diem cube. Understand? Right? That's a formula. So you beep, you get 0.296 moles per Diem cube. Okay. So now to find the last one here, they ask you for in grams per Diem cube. Again, for easy sake, you use the formula number 2. Okay. What is this? Concentration in grams C1C, grams per Diem cube equals to what? Molarity or moles per Diem cube times what? Times your MR. You see it? Very simple, isn't it? So what is one here? The molarity is here. Okay. 0.296 times. I can do fast because I've done my homework. See? You guys are shake legs only. Do it again, okay, until you get the dumb thing in your brain. Okay, MR for NaOH is how much? It looks easy, but you do it again, repeat, close the book, don't look at the book. Can do or not? You can do then, okay. You can't do it again and again and again until you get it. Okay, don't think it's very simple, okay? You first think life is so simple, see, your father pay a lot of money for you to become a shit leg. 40. Because how much? Okay, the answer is 11.84 grams per Diem cube. A very decent answer. Okay? Okay, now I'm done with you strong acid and strong base. Now let's do some weak acids. It's a bit more challenging now. See, I've given you this question from this James Strong book. Okay, you have to give some credit. He's a very good teacher. He writes all books in my time, Form 6. Okay, now see here, 25.0 simple solution, right, containing 16.0. Now they want 6.00. No, this is the old time, they don't care. Okay, substituted ethylene acid right here. What does it mean? Hold on in. This Form 5 done already. 24.5 grams of cm cube of 0.1 mole should be now. This one should be 0.100. Okay, to be accurate. Now it's more accurate. Okay, of NaOH for transition. Find the atomic mass of X. Okay, here. Okay, now remember this is called a monobasic acid. This is called a tribasic acid. I got one more here. Okay, we'll do it. Called dibasic acid. Wow, how does it look like? I'll show you how it looks like. Because finally, you see, in your passing question here, citric acid is found in the lemon juice. Now look at this. What is it? Acid? Monobasic, tribasic, dibasic, or tribasic? It's tri, isn't it? See, there are three functional groups here. 1, 2, 3. Exam come out like this. So you don't practice, how do you know? You flunk F, fail. F-A-I-L. You fail, you fool. I tell you, first thing is very simple. Okay, now mind, let's try to do that. You have to learn how to do it. Okay, now let's do the first one here. How do you attack the thing here? Okay, question 4. See, I put today, I'm very smart, you know. I put another piece of paper. I'm going to draw all the place there. See, you couldn't do. Now this one here looks like what? Now let me draw for you. A carbon has got 4 bonds. All right. So it's X here, and X here. Of course, the carboxylic must be the A here. Okay. You have to know this. Right? Don't go to the form 5. Okay. Right. That means this one will come out. Okay. 1H will come out. Here nothing comes out. Plus your NaOH again. Okay. Very simple. So when it comes out here, this plus this one here give you water, and Na goes in from the salt, isn't it? So give you the salt. C, H, H, and H, X here, X here, and C double bond O and O. Remember the minus, isn't it? Dot, remember that? In my class, you forgot, okay, I tell you, plus Na plus salt, isn't it? This is the ionic salt plus what? Plus water here. Okay, equation balance, all right? 1 is to 1, so 1 mole is to 1 mole. Give you 1 mole. One more. Okay, this is stoichiometry. Now put the details. Details, my dear friends. Okay, not your tail, okay? So here of the carboxylic, sorry. This one here. Okay, of your acid. So this is a mono substitute, okay? You don't want X only. So here V1 is equal to how much? 25. Do this, I want to see all this done. Don't be too smart and skip this step. I will slap you, I tell you. Okay, now here concentration is equal to what? 16.0 grams per dm cube. Okay, now mind. This one here for V2. Okay, put like that. Do as I do. Okay, unless you're better than me, then don't look at the YouTube anymore. You can just look at what I do, but so I don't care about you. You fail is a problem. You get A plus, that's yours. So I have nothing to contribute to your life. Okay, M2. For the rest of you, I am responsible. You don't want me to be responsible, tell me. I can kick you out of my class. Very simple. You're too proud to exceed you. Get out. Okay. Now, you find, now here they don't give you step by step. You have to use your bloody brains. No. Last time, my time, we use the brains. Now they leave you step by step. So simple nowadays, I tell you. Okay, never mind. Now, known to the unknown. You want to find X unknown, is it? This is known. So start with the number of moles here, okay? Always number of moles, because why? The number of moles, because in here you know that 1 mole is 1 mole, right? So number of moles will help you. So first of all, number of moles of NaOH, very simple. Known to the unknown, remember? Known to the unknown, known to the unknown. To known and to beyond. Oh, this is Disney, I don't know what I'm talking about. Okay, so what's the what? M1. MV over 1000 is because what's 0.100 times 24.5 over 1000. Okay, so here I've got it here. Let me just quickly write down the answer for you. It is equals to, actually you can see here shift 1 is it, right? The shift here shift, sorry, here shift back 1 come 1, shift forward. Okay, here shift 1, 2, 3. So it's here 1, 2, 3. So 0.00. 0.00. This is what I learned in my standard, my form 1 now. Okay, right? Moles. Okay, so now can I find to the unknown? I know this number of moles reacted. Right? In my 24.5 cm cube. So reacted with what? With this acid then. How much is it? So how many moles reacted? So number of moles should be same or not? Because number of moles of acid. Put acid here so that it's easier for me. What number of moles of NaOH? What is it equals to? Ratio is 1 is to 1. Acid is 1 over 1 here. So how to find number of moles of acid reacted? Very simple. So I put over here so that I've got room here. So number of moles of acid reacted is equals to number of moles of the NaOH, 0.00245 times 1. Same as it, 0.00245 times 1, or there's more moles, okay? Now this moles is dissolved in what volume? Very important, always look it up. Dissolved in what volume here? 25.0, okay? Because it's a titration, isn't it? So it's 25.0 cm cubed. Okay, now therefore, can you find the molarity? Because you need to find X and the MR is not. So molarity is equals to, right? Number of moles over volume, which is how much here? 0.00245 over volume 25 over 1000. Why 1000? Because it must be in Diem cube. Right? So I worked it out for you, my dear friends, lazy buggers, 0.0980 moles per Diem cube. Okay, so how to find X? Very simple. I need to find the MR, so concentrations in water. So I use the equation I told you. Very, very useful concentration in grams per Diem cube. Right? Because what? Molarity in moles per Diem cube. Always remember this. I don't want you to do some backstreet way. Unless you're backstreet boys. MR. Alright. So what's the grams per Diem cube given here? 16. Okay. So 16.0 equals to, what is this? 0.0980 times MR. Now MR, you can see that is what? This is your CX3COOH. Okay. So C, so it's 12 plus 3x, okay, put down, okay, plus 12 plus 2 times oxygen is 32 plus 1, okay, right? So the whole thing is equals to, if you want to put it down here, okay, is 16 divided by 0.098 is equals to, I got here is 3x plus 57. It's true, isn't it? 12 plus 12. No, something is wrong. 12 plus 12. Okay, 24. Correct? 24 plus 30, 34. Oh, no, 33 lah. Right? 12 plus 12, 24, 32 plus 1, is it? Okay, so it's 58. Or 57. 3 years, sorry. Yeah, Mr. Lai. Okay. So 3x is equals to, you work it out, 106.27. So x is equals to 35.4. Okay, obviously it's Cl. See? Right? So it's Cl. Let's try trichloro. Okay, it's a very common acid in your lower 6, okay? If you want to continue. Otherwise, drop chemistry. Okay, all right, now this is the first one here, all right? Now the second one, 3, no place, never mind, I do it, okay, this one here, all right? Okay, C2N and H2HN, triple, okay, now let me show you how it can, I will save space here. Okay, now remember carboxylic acid, you can write up or down. Okay, I'm going to put it straight across here, just like the exam, you know. Okay, I'll put that. I don't know why it's like no ink like that. I don't know what's wrong with this. Okay, let's try again. See? What's wrong? Put red. Okay, change color. Don't want to give me, okay, now mine. Now here, remember if the 3 carboxylic acid group, I must put a carbon here first. Okay, and that was branch off. Okay, put another one. Because otherwise cannot double taro, is it? There's 3 here. And of course, how many H here, I don't know lah. Okay, doesn't matter, can be whatever, so don't know, okay? But the N here will be a carboxylic acid. Okay, whatever can be branched in, don't care. This whole thing here, don't care. Okay, so 3 here, obviously plus NaOH. Yeah, so 3 is not, because the 3 one of these, right? 1 is it, so 3. which actually will give you, you want form 5, guys? I tell you, first of all, learn nothing from form 5. Okay, one here, and here, C double bond O, of course, O minus and Na plus, right? Yeah? And whatever is H here, of course, whatever, don't care. And here, same thing here, O and O minus Na plus, of course, plus 3 water. So here's 1 mole is to 3 moles, isn't it? Yep. Okay, for sure, that is what you know already, because that's what they, and other things can find from here. So here it says a volume is 25, and here 20.0 of this case, so it's volume here. So now to save space, so put volume here is equals to V1 equal to 25. Okay, 0 cm cube. And the concentration is, I think 20, is it? Let me have a look again. It's 20.0 grams, okay. 20.0 grams, okay. 20.0 grams per dm cube. What the learn, what information is given? Okay, 28.5 and 2.25, okay, 20.5, 25, 20.5. So here the V1 is 28.5, molarity 2, sorry, is 0.25 moles per dm cube. Okay, I want to find this one here, right? How many carbons here on, okay, which you see up here. I'm going to draw it for you, right? Right, C2NHN. Okay, this is actually CNH2N, I think, bracket COOH3. Okay, CN. Right, sorry, 2N, C2N, C. I also forget. Okay, let's erase this. Doesn't matter. Life is not really erasable, but this is erasable, so it's okay. So 2N, N. So you need only to find the N one, one variable, very simple. Okay? Known to the unknown. Known to the unknown. Known. I find number of moles here. Unknown. Okay, so here, of course, find number of moles first. Number of moles of NaOH. What? MVO1000, yeah. So it's what? 0.25 times 28.5 1000. Now, as I've done for you, this is equals to 7.125 times 10 to the power of minus 3 moles, okay, moles. Okay. So, how many moles of acid did I use? Fantastic. So use again the ratio. Number of moles, I'll put acid here, okay, easier. Over number of moles of NaOH. How much is it? Okay, 1:3, yeah. 1 mole to 3 moles. So number of moles of acid reacted is 1/3 times 7.125 times 10 to the power of minus 3. Yes or not? Okay? Okay, so this is actually equals to, I found out here, 0.2375 times 10 to the power of minus 3. Okay, so the molarity of the acid is number of moles over volume. Remember this dissolved in how much? Dissolved in how much of volume? And look up again the question. How much volume? 25. Okay, yeah. All right, 25. So this 25. So in 25 cm cube. So this is equals to the number of moles 0.2375 to the power of minus 3 over 25 over 1000. Remember? So it's been Dm cube. Yeah. So this is equals to, if you look it up, you work it out like I have done for you. Lazy fool, 0.095. Okay, this will be moles per dm cube. All right. So how do you find your N? Very simple. Again, use a formula. Concentration, grams per dm cube. This is given in equals to what? Molarity, moles per dm cube. What? Times MR. Okay, what is the constant given? In this case here, it is what is given here? It's given as 20.0 now. You see here? Okay. Go over again on your time, okay? 20.0, 20.0. What is the molarity given here? 0 0.9, 0 0.9, 0 0.9, okay, 0.095 times your MR. Okay, the MR first. So MR is equal to, if you find out, it will be equals to, I did it here, 210.5. Okay, now MR, remember it is what? C2NHN and bracket COOH, bracket what? Bracket what? Bracket 3, isn't it? Let's look at it again. If you don't know, look again. 3 is it, right? See, bracket 3. So down here, so okay, bracket 3. So equals to what? Now carbon is 12, so 2n times 12 plus n times 1 plus 3 times, inside is carbon 12 plus 2 times 16 plus 1, putting bracket. So here's 24n plus n plus, how much is this? It's 32. 32 is 33, that means 33 plus 12. 45 times this one here, okay, 45 times 3, 15, 1, 1, 2, 1, yeah, 1, 2, 1, 135, 135. Okay, so you bring it over, all right, actually you bring, so it's 25n, okay, 25n, let me check out here what I got here, yeah, 25n, all right, plus 135 is equals to 210.5. So you want to find out 25n is actually equals to here is also equals to where is it? 75. So is that equals to 3. So it's actually C6H3 bracket COOH3. Is that clear? Now you need to practice a lot. Okay, now the second one. Right now here, this one here. Same thing, isn't it? Now you want to draw, I won't do it for you, you do it yourself. Okay, now see here, a solution contains 5.31 grams of acid, okay, per Diem cube. Per Diem cube already. Okay, that means this will be in grams per Diem cube, isn't it? Right? Now this one here you can draw. Remember, this one here you draw at the end, is it not? Easier, draw the end like that. See now, and here look at the CH2 and don't know how much you don't care. You work it out. It's not. Of course, if there are 2 function groups here, you need 2 moles of NaOH. Yeah, to give you, of course, 0. Now this is your, why I put like that? Because it's ionic, isn't it? Yeah, yeah. Bracket CH2, bracket N, of course C bond O, O minus here, Na plus, N plus water, 2H2O. Right? Okay? Now the only thing different now here, of course, is they say hydroxyl ions. Never mind. Alright? Alright? Containing here. Okay, now just have a look at it first, okay? Now, they say that this fellow here, alright, which means this, let's put on the details first. So here the concentration is equal to 5.31 grams per Diem cube. Of course, it says per Diem cube. So the volume of this is, okay, this is V1 is equal to how much do you use? 25.0 cm cube. Okay. Now this one here is NaOH, but they say it's not NaOH, not. They say OH minus. Doesn't matter. Okay. So in that case, if you don't use NaOH, you don't use this one here, you use OH minus. Can also. That means it can be KOH on. Yeah. So the general idea is minus here. So you try first here, then put to be the same thing here. So in this case here, you don't put the Na plus. Okay. You can omit this out. Which means you use on here, what's the answer here? O minus to C dash, or you put the ionic form. CH2 and you guys copy that one nicely, okay? ionic form, that's all. No problem. Okay, so same thing happened. So here, say how, okay, that means that here will contain the concentration. This C1, this C2 equals to how much? 1.70 grams per dm cube. Can you change the molarity? Can. Molarity equals to what? Over the MR, is not? Which is 1.70 over 17. 0.100 mole per dm cube. Okay? Because OH minus is 16 plus 1. Okay? Work it out yourself. Don't go and all depend on me. Okay, right? Neutralizes. Now the volume given is 23.6. So here V is M2, V2 is equal to 23.6. Right? Okay, so now they ask you to find what? How? Okay, here. Right? I think I missed something. Did I miss something? No. Okay, correct. 20. Yes, I mix up this one. Idiot, what did you tell me? 22.5. 22.5 here, not 23. See, I upside down it further. Erase. Erase, okay now. Erase. Okay, let's go back to draw. How much is it? Say mix up. 22.5, okay? 22.5 here. 22.5. Oh my. Okay. So, to find known to the unknown, known molarity here, okay, to the unknown. Okay, number of moles of any of OH minus, okay, now. Okay, use OH minus since all OH minus in. Okay, NVO1000, no problem. 0.1 times 22.5 over 1000. Okay, what is the answer here? I've got it all written out here for you, man. See how nice I am, huh? Don't put a like some more on my videos, huh? What? Like you first useless. Okay, where is the Gundu? Where is that? 22. So forgot where this crazy thing is. Let me see how we. Okay, here. Okay, I got it here. So to make it easier, I don't have to calculate all over again. Okay, this will be 0.00225 moles. Okay, so how many moles of my acid reacted? Remember, it's 1:2, isn't it? Right? So number of moles of acid over number of moles of OH minus. Okay, it's 1/2. So number of moles of acid is equal to 1/2 times what? 0.00225, which is equals to, how much is it? 0.001125. 1125. Dissolve in what volume? The acid, 25.0 cm cube. Okay, here. You see it? So now can you find the molarity now? The molarity of acid, obviously you can find. Okay, so the molarity of the acid, M of the acid is equal to number of moles over volume. So the 0.001125 over the volume, 25 or 1000. Equals to, if you were to do it out properly by yourself, equals to 0.0450 moles per dm cube. Oh, now to find the unknown N, is it not? Yeah. So I got molarity. Am I given the concentration? Yes. Yeah. 5.31. Okay, so I use the formula again. Concentration grams per dm cube. So it's very useful. This is formula. Molarity moles per dm cube times your MR. This is where you get your stuff here. How much is it again? Concentration. How much is it? 5.31. 5.31. 5.31 equals to molarity is 0.045 times your MR. So as MR equals to, I got it here, MR is equals to 114. Okay, now let's look at the formula again, guys. Okay, CH2N again, right? CH2 bracket N, and C is a dibasic acid 2. So here is N times 12 plus 2, isn't it? Plus 2 times 12 plus 32 plus 6, 1. Okay, so here's how much here? Here's 44, 45, say, so it's 90 here. Plus how much is this? 24N, right? So 24N plus 90 equals to 114. Yep. So 24N is equals to 24. Okay, 114 minus 90 is 24. So N equals to 1, sub 2. What's the formula? CH2 COOH bracket 2. Or looks like this. You want to know the whole thing like that, and this is just CH2 here. Okay, it's a propanedioic acid. You learn this later. Okay. Okay. All right. Now let's quickly go on. Now this one here, I leave it to you to do. Okay. Example 4, right? It's a bit tricky one, but I want you to try. Okay. I want to go to something here. This is more common now. Okay. Let me check the time first. What time do we start? Never mind. Okay. Now here, citric acid is found in lemon juice. Now this is the formula they give you. Now all these brackets here you will learn later. Okay. Now let me just draw what you call the real formula. Okay, or the I forgot. Okay, you actually draw the whole formula. Okay. Now this, remember. Now this one is your functional group. Carboxylic acid. Here's a functional group. Bracket means the bracket means that this one actually comes from a bond to here. This one is a bond to here. Okay, that's what the bracket means. Okay. So the last one, of course, is like that. C double O, O and H here. All right. And then join to C and H here. Okay. So displaced formula. Displaced formula. This is a name for it. Displaced formula, which means you draw all the bonds out. Okay, so you have a very clear idea. 2, carbon. Remember, the OH joined to here, so you put up or down again. OH here. Is that alcohol? Then down here. So draw the whole thing out. Double bond O and H. Okay, and here continue to C and H here, and then to one more carboxylic. See, remember, 3 carboxyl, tricarboxyl. Of course, you write with here how many moles of NaOH? Obviously 3, isn't it? So you can see 3 NaOH. Okay, of course it will form. You want to know O minus here, I told you minus here, and of course Na plus here. So ionic compound, CH, C double bond O here, CH here, COH here, CO double bond O and O minus is an ionic compound, organic but ionic. Okay, H and H here, and again here. Okay, O minus and Na plus. Plus, of course, 3 moles of water. This is a full equation. Okay, so now this question is very simple. They give you a lot of hints here. What is the volume of a 0.4? That means here the molarity of this is equals to 0.4 moles per dm cube. They didn't even put 0 here. Never mind. Required to neutralize a solution containing, here they give you 0. They found for you already in moles. So simple, right? So from here, what's the stoichiometry? 1 mole, right? With how many moles? 3 moles now. Easy, right? So 0.005 moles, how many moles? Of course, times 3 now. Or if you want to be foolproof, number of moles of NaOH. Put the unknown first over number of moles of citric acid. Because how much? 301. 3. You know it. You have to know this, otherwise cannot. So the question based on the idea of balancing equations. So number of moles of NaOH is equal to 3 times, what is this? 0.005, which is equal to, of course, 0.015 moles, right, of NaOH. We have a concentration of how much? 0.4 moles per dm cube. Can you find out what's the volume? Is this one? Okay, so can molarity equals to what? mv. What is it? What am I doing? I look at the time, I forgot already. Now mind. Okay, here we go. Draw baby. Okay, number of moles over volume, very simple. So V is equals to M over N, is it? So what's the molarity? 0.4, right? Yes, not. Okay. What's 0.4, is it? 0.4. Yes, 0.4 here. Okay, yeah, 0.4. Right, and how many moles is it? 0.015. So what's the answer? Answer is, I got it here. Okay. Right, remember now this one you must times, this is, sorry about this. Now this is will be dm cube, okay? Okay, this will be dm cube. So you want to change to cm cube, you times 1000. So I erase this first, okay? Because my whole answer is given down there. Erase first. Remember, this is in dm cube. So for cm cube would be 0.4 over 0.015 times 1000. The answer is 37.5 cm cube. Okay? Right? 37.5 cm cube. Which is really, what's the answer? C. Understand? Okay? Right. Now, last one. This one comes up in a beautiful question. I hope we have time to finish it. I hope I don't take too much of the time. Okay? Now see here it's given. R is the weak diprotic acid, dibasic. Okay, I explained to you before, isn't it? Very soluble in water. Solution R was prepared, which contains 1.25 grams of R dissolved in this solution. When 25 cc of this solution was saturated with 0.100 mole per of anyway, 21.6 of liquid. Now, in such a paper 2 question, you have to draw it out. Okay, how to draw it out? Very simple. All right, now remember, you have this one here. So I put a dish here containing R. Okay, here is the mass as R. The mass of R here is 1.25 grams. Okay, draw it out. And you're gonna put this into a what you call later. This is called a standard flask. Okay, which has a mark here. You fill the water up here is exactly 250 cm cube. Okay, so you put inside here. Okay, you dissolve it. So make a solution here. So here make a solution of R. Right? Then when 25% of this solution, so you pipette here into a conical flask. Put here. Okay, that is a solution R here. What volume is it? V1 equals to 25.0 cm cube. Okay, titrated with 0.1 mole of innovation. So put a period here. Draw it out. A picture paints 1,000 words. It's a famous Chinese saying. So it's very wise. You all blind cows, I know. So here, what volume do you use? So V2 is 21.60 cm cube. All right. Okay. And what's the molarity of NaOH? M2 are known to the unknown 0.100 moles per dm cube. Okay. Normally, in this kind of question, they will lead you so simple. Okay, for complete reaction or complete neutralization. Okay. Okay. Using the formula H2X. Why H2X? Diprotic, isn't it? Because why? One mole of this here react with 2 moles of NaOH. To be diprotic, it means one mole of the acid contains 2 ions of H+. This is 2 negative, right? So of course, if we use sodium Na2X, it's not because it's 2 negative. This Na plus, so it's 1 plus water. So that's why it's 1 mole to 2 moles. This of course is correct here. 2 moles of water. Balance equation. All right. So above data, calculate the amount of moles of NaOH, known to the unknown. Okay. Now, if I were you, I will repeat out here because I don't want to spoil up this whole thing here. 2 moles of NaOH and put all my details. Follow something fixed. A skill means that there's a pattern to follow. Follow the pattern. Follow the route. Okay, Na2X plus 2 water. Now put down here, right? V2, how much you use? 21.60. See, a pattern. You always go for patterns. So your brain works. I know how to the route. Do this first. Do this second. Do this third. So you know the pattern. Moles per dm cube. Okay. Now here, what volume do you use? Use 25%. Yep. M2 you don't know. M1, sorry, M1 you don't know. So here, from the above data, find the number of moles of OH minus known to the unknown. Okay. Now define OH minus, huh? No, but here is NaOH. Never mind. So here, of course, the number of moles of NaOH is equals to MV over 1000. Okay, known to the unknown equals to what? 0.1 times 21.6 over 1000. So here you move 1 here, you move 1 here, you move 3 here. 1, 2, 3, 1, 2, 3. So it's 0.00216. Okay, check in my notes here just to make sure that I'm correct. Okay, correct. Now remember, this is the number of moles of NaOH. Now NaOH, 1 mole dissolved in water completely give Na plus what? OH minus now. So 1 mole to 1 mole to 1 mole. So the number of moles of NaOH is equals to the number of moles of OH minus. Yeah, so same. So the same as number of moles of OH minus. See? So they want number of moles of OH minus, give them now. So number of moles of OH minus. Okay? Right? Because here is with NaOH, it's equal to the same, which is 0.00216 moles. Right? Okay? Reacted. Use answers to calculate the number of moles of R present there. Okay, right. That means the number of moles of R is simple. You can use NaOH or something, doesn't matter. Which means here, see here, now this is R, isn't it? So 1 mole is to 2 moles, right? So same here. So here, number of moles of R over number of moles of, can put NaOH or OH, up to you. How many? 1 over 2, isn't it? Yes, not. Why? 1 is to 2. 2 of NaOH, yep. Okay. So number of moles of R is equals to half times what? 0.00216. Yep. Okay, which is equals to 0.00108. Now this number of moles is present in what? Present in what volume? In 25 cm cube. In here, guys, in here. But this came from here, isn't it? So for 25 cm cube, there's the number of moles. How about 250 times 10? That's not. So you go backwards, it be times 10 the number of moles. That's not. This is a very common question in your practical. Okay, now. So right, so remember, calculate the number of moles of R in 250. So from 25 cm cube contains what? 0.00108 moles. Therefore, 250 contains, of course, 0.00108 over 25 times 250, or just times 10. Normally just times 10, 0.0108 moles. Now this 108 moles come from how many grams? How many grams you put inside to dissolve it? 1.25%. That's not. So here, this number of moles, this number of moles, and the mass is how much? 1.25 grams. See now? Okay. So can you find the MR? Obviously, N equals to what? M over MR, is it? Fools? Okay. So 0.0108 equals to what? Mass is 1.25 over mR. So what's mR equals to? You don't not hit. 1.25 over 0.0108. You work it out, it would be 115.74. Okay, I think I got an answer here. Okay, 115.7. Okay, so 115.7, 115.74, 115.77. Okay, see, now see the method they work out, right? Equation, but they didn't tell you that here. Number of moles of any OH, you to show it, you need to write this any equation. Okay, any plus which minus. So 1 mole is to 1 mole is to 1 mole. So number of moles of here is here the same. That's why I can put this one here. Okay, right? Every step of the way. Okay, I think I'm done. Let me see, I'm done now. Okay. Yeah, now this one is next time. This is a big one. I thought if you want, I can got 5 more minutes. I think you want me, I can do this one here for you. Okay, this one here. Right? This one here. A solution containing 0, I tell you what, I would hard to see that. Okay, I will go to here. See it's from here, see? Right? A solution contains 0.063 moles of a base M. See, this is a bit different here. MOHN. Okay, so this solution neutralizes so many of sulfuric acid. Okay, so this will represent well a challenge for you. Yes, remember this sulfuric acid, but they say in hydrogen ions, which is easier to do. So it's H plus ions, and of course this is a base here. Okay, base here, that means 1 mole of MOH. Now this will test your understanding. Will give you 1 mole of M, right? Now here is 1 minus, so here will be N plus now. So you have to think in terms of arbitraries plus NOH minus. Okay, right? So 1 mole give you 1 mole and N moles of OH minus. Okay, now this is the thing. Maybe I'll just do it here for a while. Okay, so now, right? Calculate the moles hydrogen and we got blah blah blah. So first of all, put the equation first. M. Okay, M bracket OH bracket N plus H plus. Don't put H to the 4. It's easier like this. Gives you what? Okay. Of course, it gives a reaction here, but the main reaction is of course OH minus plus H plus. Gives you H2O. Okay. Right? Because this one will give you the OH minus here. Okay. Right? So this one, don't care about the M first. Okay, so they say here this moles of this one here, right? This number of moles is equals to the details are 0.63. Okay, per Diem cube. So it's moles. So we can put molarity here. 0.063 moles per Diem cube. Okay, right? Right. So the volume you use how much here is equals to 21, 25.0 cm3. Right? Neutralizes the acid. The acid here, V1 or V2, V1 equals to 23.6 cm3. And it contains the molarity of H plus, 1 here is equals to 0.20 moles. Remember, all must be a H plus, all H plus. Right? So known to the unknown, all is H plus. Forget the H also 4 first. H plus. Okay. So from here, can you find the number of moles of H plus? Can I say? Right? So number of moles of H plus is equals to same thing. MV or 1000. What's M? 0.2. Why not? Okay, I put here 2. Can't see very clearly. Right? 0.2 times, okay, 23.6 or 1000. Okay, so number of moles of H plus. Okay, so it will be equals to Wait, I want to see if I can do it another way. Now my save. Okay, so here be 4.72 and 10 to the power of minus 3 moles of H plus. Okay, so now from here, one more, let's say one more now, yeah, to form your water. Okay, so you treat some first. So here one more to one more, so the number of moles of OH minus over number of moles of H plus in this fraction is equal to 1 over 1. So number of moles of OH minus is equal to how much? Same as I said, which is 4.72 and 10 to the power of minus 3. Yes? Now this is found, dissolved in what volume? Dissolved in 25.0 cm cube. That's not. Yep. Therefore, okay, can you find the molarity of OH minus? Okay, can I say number of moles over volume? So be 4.72 times 10 to the power minus 3 over 25 over 1000. Yep. Yes. Okay, which is equals to 0.1888 moles of OH minus. Okay, in what? In 1 Diem cube. Oh, sorry, 1 Diem cube. Okay? All right? Okay. So remember, now let's go back to here. So MOHN gives you MN plus NOH. That means one more give you N moles. Yes? It's not. So they ask you for what? The question here? Calculate the mole. N is not. N. So what is N? Okay? What is N? Okay, now you know from here. How many moles you use at first here? Starting of MOH. You use 0.063 per Diem cube. Okay? So here the molarity of it is 0.063 moles here. Okay? And how many moles of OH minus here? Is 0.1888 moles here of this one. Okay? So the number of moles, so find N, of course the best thing is number of moles of OH minus over number of moles of NOH, or let's say I put A lah. All right, look at N lah. Is equals to how much? 0.1888 over 0.063. Yes? Now you look it out here, it's equal to 3. Okay? So go back and try it on this question. Right? I've done every type of question for you for acid base. Now the next acid base, of course, we call a back titration, which is very common. Okay, in here. Okay, did here. Whoops. Let's see. Okay, all this I've done. Okay, right here. I've yet to see all this. I did already. All my homework done already. Okay, so I thought I can do it, but now my time's up. So continue to do it. Practice. Perfect. Practice makes perfect. You have to do it again and again. Close the books. Repeat it until you can get it. Okay. All right. All right. Stop sharing. How to end.